Alright, so in the last video we talked about 3/4 being the ratio, right? We said 3/4 is the same as 0.75, and that's the same as 75%. And we're saying, well, why is that? Well, let's look at that with a little more explanation. So why is this the same as 0.75? Because what this says is, this actually says 3 divided by 4. That's what this per means. And this means there's 75 per 100. Right? 75 over 100 is equal to 0.75. And when we looked at that pie graph, we cut it into fourths. Fourths is our base, right? Because that's our denominator. Denominator's on the bottom like a base, easy to remember. And then we are concerned with 3 of those slices. And that's what it'll look like, right? If they're cut evenly. And then if we cut the pie evenly into 100 slices, right? I'm not going to do that, but you can experiment with that and create your own proof there graphically. And you color in 75 of those slices, it's going to look the same. You're getting the same amount of pie. Okay? So that was the comparison that we made. But then we also talked about something called a ratio. So we said it's the same as a 3:4 ratio. Well, what does that mean? It means that our numerator is over our denominator and is contingent upon our denominator. So let's clear this out, and let's say we have a hang glider, right? And there's the pilot underneath the hang glider. He's flying and he's loving it, right? Now that glider has a glide ratio. He's on this hill here. And let's say it has a 3:4 glide ratio. So for every 4 feet up, we can glide 3 feet out. So this tells us the ratio at which that glider is going to move. So if this is 400 feet in a straight line, so above sea level down here, right? This slopes out. He's going to glide out 3 feet per 4 feet. So if we have 400 feet here, right? 400 feet, that is 4 feet how many times? 100 times, right? So we increased this by 100 along this axis or this dimension right here. The ratio means it's whatever happens to 1, this is contingent upon. So if we multiply this by 100, we have to multiply this by 100. So this tells us how far he's going to glide, neglecting any forward air resistance that might be slowing him down. He's going to glide out 300 feet. And so we'll say that that's about that. So he's going to go out about this far. That wouldn't be very good for, he wouldn't make a very far flight, but we see the principle the same. So that's what's being talked about there. And in future, we're going to see more of these axes. So we're going to see a y-axis, and we're going to see an x-axis. And then we're going to see rates of change, y per x. Okay, so hopefully that kind of explains a little bit what's going on with the ratio. Obviously, when I tutor on Skype or in person, we can go into more details. Right now, I'm just kind of guessing what sort of things you guys might have questions with, but hopefully you still got something out of it. All right, cheers.